Okay, so I wanted to do some more tests, and I made a slightly better system. So let's not worry about this one right now. I'm not going to change anything. So basically, this is floating on. It's frictionless, so it looks like ice, but there's no, it's allegedly frictionless, which you can't really get, but Um, we're just kind of looking at the physics behind it. So I put a big gold ball here, so when it falls, it hits this and makes it go better. I put a rope on here. In my last video, I put a chain, and that actually changes things a lot when you have a chain up there because it shakes this thing around and it keeps it shaking down the way it the way it works is the chain will just rattle this thing down the farther it goes. So it's better with just the rope. Obviously, in real life, it's not going to work that way. This is just a simulation, but this will show you the mechanics. And so I added this counterweight here just to kind of make it so this isn't, making everything all screwy. So same mechanics. This thing just falls over, hits this swings back and forth, and then so you can kind of watch what happens. Boom. Right. So let's go back. You see we're here. Right. It shifted over because this thing's falling against that. Right. And now it's just kind of rocking back and forth. Okay. So the the motion you see here is now the same. Right. So the same amount of force went into here. So let's go back. And what I did with this one, just to kind of show you, I went in here and I set the same setup, but I put 1.8 meters per second of force into it going this way. So it's as though I hit it with this. It's almost the same impact. So I'm just mimicking the same impact when it starts. So watch if you play it, see, does the exact same movements, right? Actually, this one is a little bit more pronounced in this direction than this one, um, but you get the idea. So let's go back here. Let's add. Let's try to get it. Let's try to get it exactly. Go a little bit less, just so it looks the same. Boom. It doesn't look the same. That might be a bridge too far, um, but you get the idea. So you can kind of just put your own numbers in here to try to get similar results, and you can see it's going to do the exact same motion whether or not I strike it from over here or not. We get an impulse at first because this one, let's go back, this one has this one pushing down here, so this slides this way as this comes down, but then when this strikes it, you get this pendulum back and forth. This just has that same momentum because you need the same force to shift it one way or the other. So, right? So when you see this one has that counter force, so that's why it's not sliding like that one is, right? It's still the same force. This one's sliding to the right, but we didn't have that shifting to the left. So this just has the same force that's pulling in that direction. So, yeah, and then the more force you put into it, again, you need some kind of like, impact to make this happen. I think I haven't figured out how to do more than that. So let's say we kick it up and really push some stank into it. Right? There you go. Swing it a dingy. Anyway, that's the Lewis drift in action. Again, this is you got to take into account you're going to have this reaction here, right? So you're going to have this reaction. It's not going to be here because you have to have some sort of impact. But keep in mind you could do it with bring a set it, bring it all the way up here. Well, you can't do that. You can do that. Just throw it around. That works. right? But again, so this one finally stopped. But yeah, that's the Lewis drift. Thanks for watching.